Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss the first three problems asked in today's LeetCode Weekly Contest 459. So let's start with the first problem. The first problem says that you are given a positive integer n. You have to determine whether n is divisible by the sum of following two values. Okay, and the first value is the digit sum, and the second value is the digit product. Let's take this example for 99. The digit sum is 9 plus 9 18, and the digit product is 81, right? So you have to check whether n is divisible by this plus this, right? It's pretty implementation problem, so let's directly jump over to the code. This is the code of first problem. So I have taken two variables, value n and value 2, and I'm going through all the digits of given number n. So I'm updating value 1 as sum of the current digit and value 2 as multiplication of current digit, right? And after iterating over all the digits, I just took the sum would be the value 1 plus value 2, and I just check if any divisible by sum or not. If any divisible by sum, return true, otherwise return false. So yeah, this is all about the first problem. Now let's look at the second problem. This is the second problem asked in today's contest. So it says you are given a 2D integer array points and x comma y coordinates, and we have to find all the horizontal trapezoids, right? So what is horizontal trapezoid? It's a convex quadrilateral with at least one pair of horizontal sides that is parallel to x-axis, right? And you have to return the number of horizontal trapezoids that can be formed by choosing any of the four distinct points from the given points, and you have to return 10 to the power 9 plus 7, right? For example, in this test case, this is one of the trapezoid because uh, this line and these lines are parallel to each other. If you look at the definition, at least one pair of horizontal side, so this side and this side is parallel. Here this and this side is parallel plus horizontal to x-axis, right? uh, this is the only condition. See here, this is one, and they both are parallel to x-axis. For example, here as well, this side and this side both are parallel to each other, and they are parallel to horizontal x-axis. Alright, so let's see how we can approach this problem. In the second problem, we have to find all the horizontal trapezoids, right? And it's a convex quadrilateral with at least one pair of horizontal side which is parallel to x-axis, right? So let's say this is your x-axis and this is your y-axis, right? Let's say uh, for this, at this particular y-axis you have five points, right? 1 2 3 4 and 5. Let's say for a different y coordinate y2, you have three number of points, 1 point, 2 point, 3 point. Can we create a horizontal trapezoid using any 2 points at y1 and any 2 points at y2? Yes, we can, right? For example, let's say we took this point and this point, and we took this point and this point. So this is one possible horizontal trapezoids, right? This and match this and this, right? See, this is one. So the thing is, because see, we only have to follow one condition, that is it must contains one pair, at least one pair of horizontal sides which are parallel to x-axis, and this satisfies our condition. So ultimately the problem reduced to find the number of pairs at this particular y-axis, find the number of pairs at this particular y-axis, and multiply them, right? So it's a number of ways to choose two points at the particular y-axis. So let's say there are m1 number of points at this particular y-axis, and there are m2 number of points at this particular y-axis. What would be your answer? Your answer would be m1 c2 into m2 c2. This is your answer. These many number of horizontal trapezoids are possible, right? So since in this problem you are given, so like it could be 10 to the power 5 possible number of y coordinates, right? So you cannot just directly uh, go over each of the pair, because this could be 10 to the power 5. So if you go brute force, it would be order of n square, which would again give you TLE, right? So what we can do, see, what is our objective? Let's say this is my particular y coordinate, and there are x number of points, right, at this particular y coordinate. So what I'm going to do, I will take the sum of uh, let's say this is x1, x2, x3, x4, and all dot. So x1 c2. So for this particular x, what would be your answer? Your answer would be x1 c2 into x plus x2 c2 into x plus x3 c2 into x plus x4 c2 into x, right? This is, these many number of horizontal trapezoids are possible if you are taking x, this particular, like if you take this as one of the y coordinate, right? So like I can simply boil down to x1 c2 plus x2 c2 plus x3 c2 plus x4 c2 into x, right? So in this way you just need the sum of x1 c2 x2 c2 and just multiply with x. That is my answer. So in this way your time complexity become order of n, right? Because now you don't have to go over each of the pair and you have to find m1 c2 into m2 c2. Just do a prefix sum of directly x1 c2 x2 c2 and just multiply with x, and this is your answer. So this can be solved in order of n. All right, so let's see how we can write code for it. This is the code of second problem. So I took a map because the coordinates can be from -10 to the power 9 to 10 to the power 9. So it's better to take a map. And then what I did, for each of the y coordinate, I'm just incrementing the number of points, right? So it is given in the form of x comma y. So for each y, I'm just incrementing that I got one unique point at this particular y coordinate. So I just incremented the value. So mp of I is the number of points at coordinate I on y-axis. Correct. Now this is my answer. This is my prefix mc2 sum. So as I mentioned in the explanation part, to optimize this problem, we would keep on tracking of the prefix of x1 c2 x2 c2 x3 c3. All right. So initially it would be 0. Now we are going through all the y coordinates, right? So this is my x. This, I mean, so the number of points at this particular y coordinate, right? This is the number of points at this y coordinate. I took xc2, like the number of pairs possible, which is xc2 is x minus 1 divided by 2. Now your answer would be, your answer plus equals to your prefix mc2 sum, I mean the prefix sum, into xc2. xc2 is the number of pairs possible at this particular y coordinate, right? So this into this. So this is your answer. Now your prefix mc2 plus equals to xc2, right? Because now I'll be updating my prefix sum, right? Because I got a new y coordinate. I just updated that and I just used the modulo equals to mod, because we have to return the answer modulo 10 to the power 9 plus 7. All right. So yeah, this is the code of second problem. Now let's look at the third problem. This is the third problem asked in today's contest. This problem is an extended version of the problem asked in yesterday's contest. So I mean, till here the definition is exactly the same, so you can check out my previous video. So I'll just quickly recap. So you are given an integer array nums, and you have to define the following sequence. The first number is x for a given integer x. Now the next number would be the pop count value of the current number, and so on. So say if I designate pop count as pc, so the first number would be x, the second number would be pc of x, the third number would be pc of x, and so on until you reach to point 1. And the pop count depth is, like in simpler term, the pop count depth is the after how many operations you are reaching to 1. Let's take 7 as an example. So if you start with 7, the next number would be the pc value of 7, which is 3. See, the binary representation contains 3 number of bit set. Now the pc value of 3 is 2 and the pc value of 2 is 1. So ultimately you reach to 1 in 3 steps: first step, second step, and third step. So this is a pop count depth, right? So compared to yesterday's problem, the difficulty comes here. So you are given two types of queries. The first type of queries is you would be given L, R, and K, and you have to determine the number of indices between L and R such that your nums of like the Popcount-Depth of that particular number, nums of j is k. And the second type of query is that you have to update your current value at that index to the new value. And ultimately you have to return all the answer of first query type, right? You have to return the answer of all the queries asked of type 1. So let's see how we can approach this problem. This is the explanation of the third problem. So I'll call popcount as PC in short. So I mean, as per the problem statement, for the given number x, your first number is x, the next number is PC of x, the third is PC of the previous number, so PC of x, the next number is the previous of like the PC of previous number, so it's a PC of x until you reach 1, right? So from this statement we can clearly say depth of f equals to 1 plus, so it takes one operation to reach PC of x, right? 1 plus depth of PC of x, right? So this is a standard equation we can write from this sequence. Depth of x equals to 1 plus depth of PC of x. And if you notice in the problem statement, your k can be up to 5, right? So for a given number, it means that for a given number, even in the range of 10 to the power 15, you can easily reach to 1. You can easily reach to 1 in at max 5 number of steps, which is true, because even though your first number is 10 to the power 15, your next number would be the beat set of the previous number, which would be in the range of 1 to 50. 1 to 50, because the binary representation can contain at max 50 number of bit set for a number in the range of 10 to the power 15, right? So you can reach to 1 at max 5 number of steps. Okay, this was one point. Now the second point is, well, if you notice in the problem, you are asked two types of queries, right? The first query of type 1 L R and some k. So, and the second type some idx value and the value, right? See, yeah, if you have solved any of the problem in segment tree or Fenwik tree, this is I mean, this would give you some kind of sense that we can use a segment tree, or binary index tree, or somewhat it is also called as Fenwik tree, right? So we will actually use this concept in this problem, because it's not possible to solve this problem without using segment tree and Fenwik tree in the given time complexity, because we have to solve a range problem, right? So whenever you are asked some range type of problem and you are being asked a query and an update in that, then definitely think of some binary search, segment tree and Fenwik tree. And we know that the max value of k is 5, right? So we will create 6 number of Fenwik trees. I'll tell you why. If you understand this problem, this problem, it's a standard problem. Like if you have solved any of the Fenwik tree problem or segment tree problem, you can easily understand it. And the last one. So this is Fenwik tree for k equals to 0, k equals to 1, k equals to 2, k equals to 3, k equals to 4, and k equals to 5. So 6 number of Fenwik trees, right? And the size of all the Fenwik tree are exactly same as n. So all the Fenwik tree have same size n, right? So it can also be treated as like index 0, 1, 2, 3 until n minus 1. So now what I'll be doing, we know that we are given a nums array that can contain n number of elements in that array, right? What I will do, for any index I, your number would be nums of I. I'll find it depth. What is it depth? From this recursion, we can get the depth, right? So let's say the depth of the number at index I is k, right? So what I will do all the magic in only the Fenwik tree who has the value exactly this k. Let's say this k is 2. So the depth of the number of I is 2. I will do all the magic in only this Fenwik tree. I won't be touching these other 5 Fenwik trees. I'll do only operation in this particular Fenwik tree. So let's say this is my k, this is my depth. So this is my index I. I will go and I'll just update 1 into the index I, because I have found one number who has the depth exactly k and the index is I. I'll just update all these numbers as 1. This is one thing. And one thing, so the complexity of segment tree and Fenwik tree is so this is a query, this is an update, right? So query and update takes order of log n. So if you are given q number of queries, so the overall complexity is order of q log n. All right. Now let's say you are given query of type 1 lrk. I will do all the magic in only the Fenwik tree who have exactly same as this k, right? Let's say your k is 2. I will do all the query and update in this particular Fenwik tree. Let's say your k is 3. I will do all the query and update in this particular Fenwik tree. So in the first query of type L and R, right? So what I will do in that Fenwik tree, I'll just find the sum of L to R, and this is the standard implementation of Fenwik tree. So let's say you are given a number L to R, a number 0 to n minus 1. You have to find the sum between L to R, and so the first query of type could be L to R to find the sum. The second query could be update any number to a different number. You can follow the standard implementation of Fenwik tree to solve this problem. So I'll just use the same logic here. I'll just find the sum between L to R. Let's say you are given a query of type 2, index to the current value at index, you have to replace it to new value. What I will do, I'll first find the previous depth. I will go in depth in that Fenwik tree. I will update it to -1 first, because now I have to remove, right? Earlier I added 1 because I had one number, but since you have to replace your older value to a new value, I will first, for the older index, I will first update with -1. It means that it will neutralize everything, it will just remove it. Then for a new value, again I will find the depth and I will update at +1. So this way your query and update would be happening only in that Fenwik tree. I won't be touching other rest 5 Fenwik trees, right? So yeah, this is I'll highly recommend to learn Fenwik tree first, because segment tree and Fenwik tree are most popular algorithm, fast in multiple interviews and multiple coding rounds. So I'll highly recommend to learn Fenwik tree as well, because in this problems, to solve this problem, I have used Fenwik tree as a implementation, because it's easy and neat and clean. Fenwik tree. See, both the algorithms can do our job and using the same complexity, but Fenwik tree is very neat and clean. So I'll follow that. So maybe if you don't understand the code, I would highly recommend to learn it from online tutorials. Standard implementation of solving range sum query. It's a problem statement called range sum query, right? And one thing, so to solve any of the problem of type range sum query, range mean query, or range max query, always think of segment tree. I have 100% of the time I have found these kind of problem always can be solved using segment tree or Fenwik tree, right? So yeah, this is all the explanation part of this problem. Now let's look at the code. This is the code of third problem. So this is this is a standard implementation of Fenwik tree. Just one difference, that since I'll be using 6 Fenwik tree, it's a 2D bit array, bit 0, bit 1, bit 2, bit 3, bit 4, bit 5 for 6 Fenwik trees, right? So this is a query and update. You can check it out from the online tutorial. The main goal of this video is to solve the contest problem, to explain the solution of contest problem, not the algorithm. So you can check it out from online, but if you want to learn from me, then please write a comment for that. So if I get few comments that to explain about the Fenwik tree, I'll do that, right? So this is a query update. Now we came to the Popcount-Depth function. So initialize all the beat array to 0 initially. Now I first created the so I first found the depth of all the numbers from 0 to 55, because from the explanation part you would have noticed, so there was a recurrence relation, right? That dp of the depth of x equals to 1 plus depth of pc of x. So this is your pc of x, so this is your depth of x equal dp of I equals to 1 plus dp of pc of I. This is pc of I. So from the recurrence relation I found the depth. Now what I'm doing here, I'm updating the beat, right? So first, let's say your number is, so I'm going through all the numbers in the given array. If your number is 1, see, so this is a corner case. If your number is 1, what is the value of k? What is the value of depth? Depth is 0 because the number itself is 1. So to reach from 1 to 1, there is no operation required, right? So your k is 1. So update at k equals to 0 Fenwik tree. What I'm going to do, I'll update. So this is k equals to 0 Fenwik tree at index I. I mean, so bit treat it as a 1 base indexing. So I just use I plus 1 at index I plus 1, update 1 because I have found one number. If the number is not 1, then you can use a standard I mean, like you can use this depth array to find the depth. So now if the number is not 1, what would be the depth? Its depth would be 1 plus pop count of the current number. So 1 plus depth of PC of I, PC of nums of I. So this is its depth. Now, so I'm following the similar approach here. Go to this k equals, go to this k Fenwik tree. I mean, whatever the depth is, go to that Fenwik tree and update 1 to the index I plus 1. Like this is done. Now we came to query part. So the query can be of two types, right? We have the first type is that you have to find the numbers between L to R who has k depth. I'm doing the same thing. I'm just asking a query, give me the sum for the Fenwik tree who has this depth, this as a depth value k. So it will give you the sum between L to R. So this is kind of a prefix sum. First get the sum till R plus 1, then subtract the subtract the prefix sum till L. So prefix of L to R is equal to, like, the sum of L to R is equal to prefix of R minus prefix of L minus 1. That's what it's a standard range sum query problem. So I would highly recommend, if you have not solved before, please solve range sum query problem, right? It's very, very important algorithm to find range sum query using segment tree or Fenwik tree. Now if it's a query of second type, so see, now you have to replace your current older number with the newer number, right? So first remove that number from the Fenwik tree. So again, if the number is 1, your depth is 0. So go to that Fenwik tree and replace 1 to minus 1, because now we are removing that number. So 1 to add, minus 1 to remove. Again, if the number is not 1, go to this depth and update it minus 1, update your nums, and then again do the same. Now after updating, you again check if the number is 1, update at this k is equal to 0 Fenwik tree as 1, and if the number is not 1, then go and update 1 to this depth Fenwik tree. So yeah, this is the code of the third problem. This is I understand this is a bit of hard version of the problem. So but yeah, if you didn't understand any of the point, please write a comment. I'll reply to all the comments if you have any query in any of the code or anywhere in this video, right? And at the end, just return your answer, right? So yeah, this is all about today's contest. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.